Hi! So this is the second part to this video on how to balance the reaction in acidic conditions. I already went through how to identify oxidizing and reducing agents and how to balance reactions in acidic conditions. So here's the outline again. So I'm going to start on the next page. Here, I'm going to split up the oxidation and the reduction reaction. So, here we go. So for the oxidation, that was already identified as I minus to I2 because it's being oxidized because it's losing an electron since it's going from 1 minus to 0. So, I'll write the oxidation reaction here. So I minus 2 I2. Let me erase this real quick. And then for the reduction reaction, red for reduction, it'll be what's left over. So chlorine ClO3 minus as it's going to Cl minus. So let me write that out. ClO3 minus goes to Cl minus. Okay. So there's that. I'm going to balance out the oxidation reaction first. So as I said in the first step, balance the elements except oxygen and hydrogen. So here we only have iodine, which is good since there's not that much work to do for this one. So you have 2 iodine here, and you only have 1 here. So you need 2 I minus as it goes to I2. Alright, so your iodine is balanced, but what's not balanced are what's the charge. So you have 2 minus over here, and you have a 0 charge here. So you need 2 electrons on the product side. So it'll be written out as 2I minus, as it's going to I2 plus 2 electrons. And that is your balanced oxidation reaction. Now I'm going to go balance out the reduction reaction. So you have ClO3 minus as it's going to Cl minus. So your chlorine is balanced out. You have 1 chlorine here, 1 chlorine there. Your oxygen, now this is where, in order to balance the oxygen, H2O needs to be added to the other side of the reaction. So ClO3 minus, as it's going to Cl minus plus H2O. But here's the thing, you need 3 oxygen. So in order for it to be balanced, you need to put a 3 in front of the H2O. Next, after balancing out the oxygen, you balance out the hydrogen. So you have 6 hydrogen here because 3 times 2. So add 6 hydrogen to the reactant side. So you have, 6 H plus ClO3 minus, as it's going to Cl minus plus 3H2O. Alright, so there's that, and then after adding the hydrogen, next comes the electrons in order to balance out the charge. So you have 6 plus here and a minus 1, so that means you have a 5 plus charge here, because 6 minus 1. And then on this side, on the product side, you have a minus 1 charge. So what you're trying to do is balance the charge to where the reactance is balanced with the product. So the only way to do this is to have the charge on both sides equal -1. So on the reactant side, 6 electrons need to be added. So 6 electrons plus 6H plus ClO3 minus, as it's going to Cl minus plus 3H2O. Okay. I know I had to squeeze it in there. So this is your balanced reduction reaction, and this is the balanced oxidation reaction. So I'm going to finish this problem on the other page. Next, once the oxidation and reduction reactions are balanced, both of the reactions need to be added up together to make up the overall balanced reaction. So first you have your oxidation. So 2I minus, as it goes to I2 plus 2 electrons. And then the reduction reaction, which is 6 electrons plus 6H plus ClO3 minus, as it goes to Cl minus plus 3H2O. So as you can see here, nothing can get canceled out. What you're trying to cancel out when balancing these two reactions are the electrons. So the only way to do this is this first equation, the oxidation equation, has to be multiplied by 3. Because when you multiply 3 for each of the coefficients, you'll have 6 electrons and 6 electrons, and you'll be able to cancel those out. So I'll just cross it out. So this will change into a 6 after multiplying by 3. This will be a 3, and this will change into a 6. So once you do that, the electrons cancel out on both sides, and then you have what's left over that makes up your balanced overall reaction. So overall, you have 6I minus plus 6H plus ClO3 minus, as it goes to 3I2 plus Cl minus plus 3H2O. So this is your balanced overall reaction in acidic conditions. So that is it for this problem. I hope it makes sense. I hope it does. If you have any questions or concerns, don't be afraid to leave a comment under the video, and you can send me an email. I'll try to reply ASAP. Hope you enjoyed the video, and happy studying. Bye.